In example 4, the function is 1 over x, and it asks again for the f prime, meaning the derivative. So again, the derivative is the limit of the difference quotient. Now, we did this problem on a previous page. As a matter of fact, this is example 6 on page 40 of the notes that you just worked on. And in that problem, we found that the difference quotient of 1 over x was 1 over x times x plus h with a negative sign in front. So this result that you have right here is from a previous problem that we worked on already. So this is example 6 on page 40. So take a look at that to know the steps if you don't remember the steps. And I made a video for that one so you can see how to get the difference quotient. Now, all I have to do at this point is remember that h is going to 0, so the h right there needs to be replaced with 0. And when I do that, I end up with negative 1 times x plus 0, which is the same thing as negative 1 over x squared. So in other terms, the f prime of x in this problem is negative 1 over x squared. That's the derivative of the function f of x. So the point is, if you have old results that you can use, you should not do the work twice, right? If you already have done 1 over x, you should take advantage of it and just use it to find the derivative. And part 2 of the problem says, find f prime of 2. So in other terms, we are looking for what happens when you plug in 2 inside the derivative. So the derivative is negative 1 over x squared, and I'm supposed to replace the x with the point 2 in this case, because that's what they asked for. They said 2 right there, so I'm just going to replace it in place of the x. And when I do that, I end up with negative 1 over 4. This is known as the slope of the tangent line at the point where x is 2. Okay, so how is this useful? Well, let's continue looking at part 3, where it says find the equation of the tangent line at the point x equal to 2. So I'm looking for now the equation of the tangent line, not just the slope. In order to do that, I have to remind you of a formula that we looked at when we were doing the review for this class. It was y minus y1 equals to m times x minus x1. So this formula basically says, you give me an x1 and a y1 and a slope, and I can tell you the equation of the line. This is a very important question in this class. It's pretty much a standard question that we're going to be working on for the rest of the semester. So you should kind of know how to do this. Now, the problem is usually going to provide you with an x1. That's the number that you're seeing right here. That's the number 2. That's going to be usually given to you. Now, there's going to be a couple of things that are missing. The m, this is the slope of the tangent line. So how do you get the slope of the tangent line? The way you do it, typically speaking, is by using the derivative, and you plug in the x1 inside of it. That's what we did in part B of the problem. The answer to that was negative 1 over 4. So that's negative 1 over 4 is going to be the m ultimately. And the final thing that's missing is the y1. So this is going to be missing usually. And how do you find the y1? The way you find it is by putting the function f with a 2 inside. Again, where did 2 come from? It's the x that the problem is giving you. So notice the notation. It's very, very similar between these two. This one says f apostrophe 2. This one says f of 2. They're very closely related, but one of them is putting the 2 into the derivative. One of them is putting the 2 into the original function. So let's make a table over here. Again, to summarize, x1 is going to be 2. That will be given. The m is the slope, meaning it's the derivative, with the number 2 plugged in. And we ended up with negative 1 over 4 when we did that in part B. And finally, the y1. It's the function with 2 plugged in. The function is 1 over x. So if you plug in 2 instead of x, you get 1/2 at the end. Okay? So again, be careful. The 2 is going to be given. Use it to get the slope and the y1. Now that you have everything ready to go, you're going to go and plug in all the numbers. So the y1 turns out to be 1/2, and the slope is negative 1/4 x minus the x1, which is the number 2. Typically speaking, we want the y all by itself over here. So what we're going to do is FOIL some things out and clean up. So negative 1/4 times x is going to be negative 1/4 x. Negative 1/4 times negative 2 is going to be positive 1/2. And now I need to just move this negative 1/2 to the other side. So when I move it, it becomes positive. So 1/2 from the earlier problem, and then we are bringing this negative half, so it's going to become positive 1/2 to the other side. So together, that's going to be a 1. And that's the final answer in this question. What I'd like to do now is to show you the significance of what we just got by using the calculator to graph everything. So I'm going to do a couple of things here. First of all, I'm going to graph the function itself, the 1 divided by x. And next, I'm going to graph the slope of the, or rather, let's graph the tangent line itself. This was negative 1/4 x plus 1. So again, here's the graph. Let me fix the window so it looks better. I'm going to click on zoom, then click on 6. That will reset the window to the original settings that it came with. And there's the graph. Now, as you can see, there's a lot of junk that I don't care about over on this side over here. I care about what's going on around 2. So let me show you a couple of tricks that you can zoom in on this area. So there's a couple of different ways of doing that. You can click on window and then manipulate the numbers yourselves. So like for example, I care about x to be 2, so I can go from minimum x 0 to maximum x 4. That will put 2 right in the middle of my screen. And on the y coordinates, I can go from, let's say, 0 to, let's say, 4 again. And again, this is just your own preference. There's no right or wrong answer over here. But depending on how you do it, if you click on graph, you'll see a different view now. So what I want to do is trace the number 2. And as you can see, it says 2 in blue and 0.5 in blue. So what does this mean? This tells me that on the regular graph, when x is 2, the y-coordinate is 0.5 or 1/2. This is true. That's what we got when we did the work ourselves on the other PDF. So in other terms, if you were to stand at x equal to 2, the y-coordinate on the graph itself, on the blue graph, it will be 1/2. Now if I switch over to the red graph, all I have to do is click down to switch over. You'll notice again that if I'm standing on the slope, if I'm standing on the tangent line at 2, the graph is also 0.5 high. So this tells me that the red line and the blue curve are touching in that one spot. And that's the only spot where they're actually touching. If you move a little bit left and a little bit right, all the numbers will change. So like for example, if I go 1.96 on the red graph, I will see 0.51. If I switch over to the blue graph and click 1.96, I'm going to get different values. It's a completely different number. The only time they're matched is at the point 2 itself. That's the only spot where the red graph and the blue graph are going to give me the same result. That's the reason why we call this red line the tangent line. And as you can see, the red line gives us a little bit of an idea of what the graph is doing. The graph is kind of going downhill, just like the line itself is going downhill. So that's another important reason why we care about the slopes of the tangent lines and tangent lines themselves. They can give us an idea of how the blue graph is behaving without even looking at the blue graph. So if I told you that the red line was pointing down, you would automatically know that the blue line is also, or the blue graph is also pointing down. That is the significance of doing all this work over here. So we get a lot of information just by looking at that minus sign right there. That's the slope of the tangent line. It's negative. So that tells us the direction of the graph is all down. So it's kind of a nice thing.